Welcome everybody. My name's Ryan Simmonds, Specification Development Director for Aliaxis. I'm joined today by Oliver Latham, Technical Manager for Aliaxis. We're going to be presenting on barrier pipe for potable water supply in contaminated land.
Thank you. Yeah, good morning all. There's a few contents slash sort of learning objectives that we aim to tick off today. So a bit on who we are as Aliaxis, what we do, contaminated land as a concept, the pipes used in contaminated land, what is a barrier pipe system, benefits of a barrier pipe system, some project references, and then a bit on project portfolio. So that's what we're looking to learn today. In terms of Aliaxis, we're experts in fluid management solutions, and we're passionate about creating sustainable systems of water, gas, and energy. And we hope we sort of lead the industry in a way of which anticipates a rapidly evolving need for customers, ensuring peace of mind for future generations. So that's a bit on us in terms of scale. So we're a big outfit. We've got a global presence. Revenue 3.1 billion, colleagues 16,000 plus. We've got a presence globally and manufacturing facilities across the globe. Just an idea in sort of the main three segments, so Americas, EMEA and APAC. And then some brands you might be familiar with. So the Vulcathenes, the Marleys, the PLX, Protector line. These are all brands that have existed long before we became sort of Aliaxis in the UK. But contaminated land, what is that? So contaminated land is areas that have been contaminated by things like hydrocarbons potentially in a fuel station, and these potential contaminants could leach into the ground, and this can have an effect on water quality for pipework that's not properly protected. So brownfield land is a term used. This is referring to land that has got potential contamination, previously used for sort of industrial or commercial purposes, and there's a known or suspected pollution that could potentially be present, and we have to cater for that. We have to engineer for that with the systems deployed. So this is a nice visual piece in terms of showing how ground contaminants can potentially migrate into the pipe system, into our water networks, which obviously is a concern due to health and well-being. So it's very important to ensure that the pipe system is properly engineered, is suitable for being deployed in brownfield sites, ex-petrol stations, any areas where contamination could be present. In terms of material consideration, and there's various materials that can be used for this application: barrier pipe systems, PE pipe, PVC, wrapped steel, ductile iron, and copper. Those are the six most prevalent, but there is other materials that you may see deployed. The thing to consider when looking at material consideration is the material's resistance to various elements that could be present within a contaminated area. So things like mineral oils, corrosive materials, ethers, ketones. These are all things that need to be considered when you're doing a pipe selection table. So this comes from the UK WRI report, and it basically gives you a breakdown on what materials and what concentration levels need to be considered. So for plastic materials, you've got polyethylene there, and those are the safe levels of those relevant elements. Similarly with PVC, and you can see some materials are better against some agents, some are inferior. So it's always a case of checking the material against the elements. PASS denotes total resistance. So if a material or a system has got total resistance, it will say pass. If there's a numerical value, that's the safe level of which can be achieved. So once you move on to the metallic materials, they're pretty good across the board, apart from when you talk about corrosive action, the corrosion of the material over time, and potential rupture. So things like wrapped steel, ductile iron, copper will corrode in certain pHs that are present. However, if you migrate to a barrier pipe, you've got consistent passes, consistent resistance across the board. So because of the nature of a barrier pipe, it contains a metallic element for the resistance perspective, and it also contains obviously a PE polyethylene, and that protects it from any sort of corrosion that may occur. So it's a nice central compromise between the metallic and the plastic systems. So this is a barrier pipe broken down. So it's designed to safely transport drinking water, and it contains multiple layers. So it's got an outer PE protection layer. It's then got an aluminium barrier layer, which is bonded between an adhesive layer, and then you've got your internal host pipe, which again is polyethylene. So it's a multi-layer pipe system. So why it should be used? It's saving time and costs of soil sampling. So typically in the UK, it's quite common for people just to deploy barrier pipe without doing a soil sample, without doing a soil analysis. It's just saves a lot of time and money just to deploy a barrier-like system, and then you're protecting those stakeholders. So you can have savings on landfill, protection of the structural integrity of the pipe. Obviously, that's paramount for the authorities. And it gives you some peace of mind that you're supplying water that's safe for human consumption. So we looked at what happens when you deploy a system that isn't suitable for contaminated land, but this is a system that is. So the contaminants may slightly purge the outer layer, but as soon as they hit the aluminium barrier layer, they will stop totally, and there's no way in which these can purge into the inner bore. So the barrier pipes generally come in different PE strengths and wall thicknesses, but typically it can operate up to a 16 bar pressure rating. Typically jointing is done either by fusion or mechanical, but we'll come on to that in a bit later. Yeah, so a barrier pipe typically needs to consist of both pipe and fittings. So a full system, a full solution. It's not considered best practice to mix pipe solutions with fitting solutions. Typically it needs to be a fully compliant system that's manufactured in BS 8588 is the standard in question. So the joint's typically required to be not only leak proof, but sort of impermeable to ground contaminants. So sometimes there may be a need to wrap joints depending on configuration. Typically an aluminium wrap will be required at that point just to ensure there's no purge. And obviously all the systems need to be fully RAT approved. So there's a couple of types of barrier pipes that existed and do exist. So on the right is the older style. That's a type B barrier pipe. So that's where the aluminium layer is integrated into the polymer and can't be removed for jointing. So this is a much thicker layer, and it means that the pipe can't be electrofused. So it makes it a lot more difficult to joint and put together. However, the type A, which is a lot more prevalent, this includes a much thinner layer of aluminium that can be scraped away and basically just leave a solid piece of polyethylene, and this can allow typical welding methodology, so electrofusion joints, but fusion. So the methods of jointing that are very prevalent in the market can be utilized on type A, not so much on type B. But type B is very rarely used and is not really prevalent. So we've mentioned jointing methods. So you get two types: welded joints and mechanical joints. So welded joints are typically via electrofusion welding, which is couplers, which contain a metallic coil that's heated, and it causes the material to fuse. But fusion is the same, but you heat the ends of the pipe and push it together, and it creates a nice bead of polymer that is fully pressure capable. Alternatively, there is mechanical joints, so sort of compression style on the left, and then more of the clamp style on the right. These are both again suitable and sold as part of a full barrier solution. Typically for smaller sizes, so up to 63 mil, mechanical is utilised, and once you step over to larger sizes, 90 mil and above, that's where the fusion weld is more prevalent. So we welded joints and butt fusion, so you've got a single pipe length, you've got sort of joint integrity, it's a permanent joint. The joints are designed to last a lifetime. And the nature of fusion is it allows a level of flexibility. So there's sort of deflection that can be applied, and it can be a bit more flexible once properly cooled and deployed. And you get a nice smooth internal finish. So you've got no inserts that are potentially impacting the flow rates or the nature of the water properties. So looking at when you're talking about butt fusing in particular, you've got to consider the SDR ratings. So the SDR rating refers to the pipe wall thickness, and that directly correlates to the pressure capability of the system. So electrofusion can be used where you're have different SDR ratings. However, for butt fusion, the SDR rating has to be consistent between the two pipes. So the wall thickness has to be consistent. So it's either SDR 11 to SDR 11 or SDR 17 to SDR 17. It can't be a mix and match as shown. So in terms of preparation, the key is to remove the external layer. So you would use a peeling tool as shown there. That will remove the blue PE layer and also the aluminium, and that will allow you to create an integral joint. It's much better to use a peeling tool as shown there as opposed to hand scrapers. It can be a very long-winded process if you try and use those, particularly on larger bore. So it's important to use the correct tooling. There's some characteristics, some generic characteristics. So P and slash aluminium barrier pipes are suitable for all conditions. So there's no areas where barrier can't be deployed. In contrast to all plastic or all metal, it's the fit and forget solution really. So it's based upon service performance of P100, so it's expected to exceed in excess of 100 years of life cycle. So again, it sort of correlates with that previous point. And obviously PE pipes don't rust, they don't corrode, they don't lose wall thickness over time, and nice and lightweight in comparison to metallic systems for transport. And that inherent flexibility that we've discussed is really important. In terms of standards and approvals, typically the system would be expected to have the following standards assigned, both manufacturing and capability. So typically the 12201 WIS, RAS is always required for any system that requires to be conveying drinking water. So RAS is integral. So those are some key standards to look into. Just some further key benefits. So it's got sort of superior barrier performance when you talk about sort of a protector line type solution. Ease of installation, RAS approval, lifetime, 100 years. It's a bit of much a reiteration what we've been over, to be honest. There's some projects examples that we've worked on as part of Aliaxis UK. So this was a brownfield site, and this was a 1 kilometre run that had been butt fused to create a long string. Sort of large sizes, 255 mil and 440 mil, 355 mil, sorry. And then the smaller spurs would branch off at 90 mil, 180 and 225. So this is sort of a typical main tributary run and quite a common application. This was an example of the Port Clarence project. So this was a new 160 mil renewable energy plant in Teesside. So there was a long history of sort of industrial works at the port, which meant that the ground was quite severely contaminated. So there was a need for the barrier system to be deployed to protect the system and protect the quality of the drinking water. Another example was in the Welsh Valley. So this was a more of a built up area. So this is where you see people digging up the roads and deploying a system. So this was quite a long run, a 15-kilometre route, done by a company called Lewis Civil Engineers, and it was a big variance of sizes, so 25 mil up to 400. Included feral offtakes, which were a mechanical means of branching off. So typically they allow a branch off from a large tributary to a smaller 25, 32 mil run that will run to the dwelling itself. It was for Welsh Water, so it's this sort of typically barrier pipes are deployed by all the authorities in the UK. In terms of a protector line as a system, so this is the system that we supply as part of Aliaxis UK. So we do pipe up to 630 mil, 63 to 630 mil on the straights. Then there's coils 25 up to 180. Also offer the 3C and the 3CTH. So that is basically pre-cleaned and capped pipe work. So that removes the need for a pre-flush on site to remove any debris that might have been introduced during transport or manufacture. So it allows the fit and forget methodology, and it removes the need for a cleaning process. Electrofusion fittings 90 mil up to 630, so a full electrofusion offering. Typically they're welded via the barcode you can see there. So you would scan that using a fusion box, and that would automatically input the weld time. Sometimes the weld time is pictured for manual input as well. For smaller sizes and larger sizes, potentially you've got the mechanical compression and the mechanical clamshell. The compression, the green insert, it goes into the inner bore of the pipe, and it creates a real sturdy, rigid fit. A similar process with the blue clamshell, where that inserts into the inner bore, and the clamshell goes around the outside. The offtakes are what I described earlier, so that basically allows you to branch off from larger hose pipes from 63 up to 355, and then go to smaller, typically final runs to dwellings or other buildings, and that's done via a mechanical means. So you can see the takeoff mirrors the mechanical compression fittings in its connection methodology. And of course, boundary boxes. So we also offer boundary boxes. These sit at as the name suggests, at the boundary of the building or of the dwelling, and that offers an isolation, a metering point, and we offer fully compatible systems that can sit within contaminated areas. So the boundary box isn't going to be a weak point; it is going to be a potential risk of contamination. It's consistent with the rest of the barrier offering. Thank you. So that's the end of the presentation. I don't know if there's any questions.